For as long as humans have looked at the stars, we have wondered if we are the only ones looking back. For centuries, this was a question for philosophers and poets. But in the last decade, it has become a question for physicists. We have discovered over 5,000 exoplanets, but most are dead, frozen rocks or hellish gas giants. However, 120 light-years away, there's a world that defies the norm. K2-18b. It orbits a red dwarf star in the constellation of Leo. For a long time, it was just another number in a database. But today, it is the center of the greatest scientific debate of 2026. Is this the world that finally breaks the cosmic silence? To understand why K2-18b is special, we must look at its composition. It's what we call a sub-Neptune. Larger than Earth but smaller than Neptune. But more specifically, it's a Hycean world. This is a relatively new term in astronomy, combining hydrogen and ocean. Unlike Earth, which has a thin atmosphere and rocky crust, K2-18b is thought to be covered in a massive, planet-wide ocean, perhaps hundreds of kilometers deep, tucked under a thick layer of hydrogen. Why does this matter? Because hydrogen is a powerful greenhouse gas. It could keep the ocean warm enough to support life, even though the planet is far from its star. As James Webb began its deep space scans, it wasn't just looking for water. It was looking for the chemistry of life itself. In late 2025, the data packets from Webb's NIR-SPEC instrument revealed something that shocked the team at NASA. They found methane, they found carbon dioxide, and they found a lack of ammonia, all signs that a liquid ocean exists. But then, buried in the noise, was a signal for dimethyl sulfide, or DMS. On our planet, DMS doesn't just happen. There are no known volcanoes or lightning strikes that produce it. It is a byproduct of life, specifically marine phytoplankton. If this molecule is real, we are no longer asking if life exists, only how common it is. A chemical that we only know to be produced by biology on Earth has been detected on a world 700 trillion miles away. Astronomy no longer just sees worlds, it smells them. And right now, K2-18b smells like life. As we move through January 2026, the scientific community is in a state of cautious electrification. The detection of DMS is, as of now, tentative. The signal is weak. So weak that some skeptics believe it could be an instrumental error or a different molecule altogether. This is how science works at the frontier. It is slow. It is meticulous. Right now, Webb is performing follow-up observations, staring at K2-18b for dozens of hours, collecting every single photon of light. We are waiting for the gold standard of data, a spectrum so clean that it leaves no room for doubt. If confirmed, this will be the most significant discovery since the dawn of civilization. We are currently living through the quiet moments before potential revolution. If K2-18b is inhabited, it changes our destiny. It means the great filter, the barrier that prevents life from spreading, might not be as impenetrable as we feared. It means the universe is a garden, not a desert. Whether the final data in 2026 confirms it or refutes it, K2-18b has already done its job. It has shown us where to look and what to look for. We are the first generation of humans with the technology to actually see the invisible signatures of alien biology. The search for life is no longer a dream, it is an active mission. And perhaps, somewhere in that distant hydrogen sky, something is looking back at us, wondering the exact same thing. The stars are no longer just points of light. They are destinations. Thank you for joining us on this journey. If you found this exploration valuable, consider subscribing to Cosmos Protocol for more updates from the edge of the known universe. I'll see you in the next one.